9.7. Graphing quadratic function by using transformations. So we talk about this back in chapter 3, but vaguely. Right now, before I even start talking about transformations, I want you to look at the following examples and then find out, do the observations of what changes from our parents' graph formula and how the graph is behaving, how the graph is changing. And then we will generalize it, you know, in terms of function notations for all the transformation process. So remember that if a function has nothing add or subtract to it, this is considered a parent's graph. Okay? And I already choose a point for you to make it, speed it up on these cases. So let's find out the value, evaluate it, and then plot the points to see where my graphs are. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So therefore, I can get my graph at 0 will be 0, at 1 will be 1, at 4 will be 2, and at 9 will be 3. And you can see that this is a square root graph. That's a parent graph, how it's look like. So you should remember these a few points to graph your parent's graph quickly and then do the transformation from here. So for the next one, take a look at it. What changes in the formula is I'm adding x by 2. Right? I'm adding x by 2. So let me recall, this is how you look at it. This whole expression is equal to f of x, which is this whole expression is indicating that will be representing my y value. So notice that if I want to add or subtract to x, I will just put next to the x. So if I evaluate it, if I plug in negative 2 plus 2 is 0, negative 1 plus 2 is 1, so square root of 1 is 1. 2 plus 2 is 4, square root of 4 is 2, and then 2 plus 7 is 9, square root of 9 is 3. So therefore, my points in this case will become at negative 2 will be 0, at negative 1 will be 1, at 2 will be 2, and at 7 will be 3. So when I graph this, that will be my parabola graph. Right here. Okay. So notice that what happened right here, if I add a number to x value, my input, okay, my input and output, there's only two, x and y, because we only have two coordinates. If I add to x value, the entire graph shifts to the left. Let's take a look at on the next example. So now I'm subtracting x by 2. So 2 minus 2 is 0, square root of 0 is 0. 3 minus 2 is 1, square root of 1 is 1. 6 minus 2 is 4, square root of 4 is 2. 11 minus 2 is 9, square root of 9 is 3. So my graph right now will be 2, 0, 3, 1, 6, 2, and 11, 3. So notice that my entire graph, the parent's graph, shifts to the right 2 units. So from this 2 example, you should what you need to grasp is if your parent's graph, the input value, which is the x part, is added by a number, then the graph will shift to the left 2 unit. If it is subtracted by a number, it will be shift to the right that many units. Now let's take a look at on the next example, and notice that this time I'm adding 2 to my square root of x, which is, remember, square root of x in a parent's graph, that's representing your y value. So I'm adding 2 to my y value now. So if I'm adding 2 to my y value, what's going to happen? Let's take a look at it. At 0, square root of 0 is 0, 0 plus 2 is 2. At square root of 1 will be 1, 1 plus 2 is 3. Square root of 4 is 2, 2 plus 2 is 4. Square root of 9 is 3, 3 plus 2 is 5. So now I got at 0 will be 2. At 1 will be 3. At 4 will be 4. And at 9 will be 5. So notice that this graph shifts up 2 units because you are adding all your y value by 2 units from the parents graph. Right? See, look at this is my parents graph. Right? You're adding all your y value 2 units. So now the next one. So you can see this time I'm subtracting 2 to my square root of x, which is I'm subtracting to my y value. So square root of 0 is 0. 0 minus 2 is negative 2. Square root of 1 is 1. 1 minus 2 is negative 1. Square root of 4 is 2. 2 minus 2 is 0. Square root of 9 is 3. 3 minus 2 is 1. So my graph now it becomes at 0 will be negative 2. At 1 will be negative 1. At 4 will be 0. And at 9 will be 1. So if you look at the graph, this graph will be same way, but from the parents graph, notice that it shifts down 2 units. So basically, if you add or subtract, right, to your x coordinate, it's going to shift left and right. If you add or subtract to your y coordinate, it's going to shift up and down. So those are the 2 things. Now, with this, let's move on to the next one, the reflections. If I plug it in 0, it will be negative 0. Square root of 0 is 0. If I plug in negative 1, negative and negative become positive, so square root of 1 is 1. If I plug in negative 4, it will become negative of negative 4 is positive 4. Square root of 4 is 2. And then square root of 9 will become 3 if I plug in negative 9. So this will become, here's 0, 0, 1, negative 1, 1, negative 4, 2, and negative 9, 3. So what happened is the entire graph, right? The entire parents graph reflect about the y-axis. Here's my y-axis, it reflected, right? The reflected y-axis. So what happened is if you are multiplying a negative number, a negative 1 to x value, the entire graph going to be reflect about the y-axis. So take a look at on the next one. If I multiply a negative to my square root of x, which is my what? Y, then the entire graph going to be reflect about the x-axis. So at 0, square root of 0 will be 0. 0 times negative will be still 0. Square root of 1 is 1, and that will become negative 1 because of outside negative. And the square root of 4 will be 2. With negative will be negative 2. Square root of 9 will be 3. And then with the negative will be negative 3. So my graph will become at 0 will be 0. At 1 will be negative 1. At 4 will be negative 2. And at 9 will be negative 3. And notice that the graph is what? Reflect about the x-axis. Okay, my graph is, I'm not drawing very nicely. So it should be a very nice curve. So let me redraw it, retry it. So now we got is a reflect about the x-axis. So far we did a few things already. So let's scroll, go down to all the way down to this page, right? Horizontal shifting, and notice that I mentioned earlier, if you are adding to your x coordinate, the input, and it will be the parent's graph will be shift c unit to the left. Okay, if your x coordinate is subtracted by a number, then uh, the parent's graph gonna be shift to the right. Okay, c units. If your y value, which is the functions, right, is added by a number, then that means the whole graph gonna be shift up c unit. Your parent's graph gonna be shift up c unit. And if the function is subtracted by a number, then the entire graph gonna be shift down c units. And we talk about reflections. If you are multiplying to a y value, right, your functions, your y value, then the graph will be reflect about the x-axis. And if you are multiplying to your x value, the input value, by negative, then it will be reflect about the y-axis. So far we got these. And then we're going to look at vertical stretching and then shrinking. Okay. So I see there's a typo right here. I don't know why it's put it horizontally. So make sure you change that to vertically. Okay. I just noticed that. Vertically. So let's move back and then take a look at on this vertical stretching. Notice that I'm multiplying my y value by 3, right? This is y value by 3, so it will be vertically stretched. So if I substitute 0, square root of 0 is 0, but times 3 will be still 0. But however, when I start substituting 1, square root of 1 is 1. 1 times 3 is 3. When I substitute 4, square root of 4 is 2. 2 times 3 is 6. And square root of 9 is 3. 3 times 3 is 9. So notice that what happened is your graph will become, here's a 0. And then 1 is 1. It now is stretched by a factor of 3. So up 3. And then 4 will be 6. And then 9 will be 9. So what happened is your square root graph is vertically stretched up by a factor of 3. So notice that the graph is like not flat anymore. It's a lot, you know, shoot up higher and faster. That is when you multiply by a number that is greater than 1. And let's take a look at on 1. We multiply a number that is less than 1 and greater than 0. At 0 will be 0. 0 times 1/2 will be 0. Square root of 1 is 1. 1 times 1/2 is 1/2. And square root of 4 is 2. 2 times 1/2 is 1. Square root of 9 is 3. 3 times 1/2 is 3/2. So we are getting at 0 will be 0. At 1 will be half. At 4 will be 1. And then at 9 will be 1.5. So notice that the graph is a lot what? Flatter, which is vertically shrinking. That's what it means. So going back down to here, Notice that if you are multiplying by c that is greater than 1, then the graph is going to be, if you multiply c to a function value, right, your y value, if c is greater than 1, then it will be vertically stretching. The parent's graph by a factor of what number you multiply with. If the value c is between 0 and 1, which is less than 1, greater than 0, then it will be vertically shrinking. So the graph will be like a lot flatter. Now, the last example at this point, observations. Without plugging in, after we talk about all of these examples, can we say where the graph, how to transform this graph? So always start with your parent's graph. Since this, when I see square root, my parent's graph will be always square root of x, which is nothing as subtract to it. And I want you to follow in this order. Always do the transformations, which is reflecting and stretching first before you shifting left, right, up, down. So therefore, the next step will be I will be reflecting, which is my parent's graph will be reflect about the x axis, because square root of x represent y. If you multiply a negative to y value, that will be reflect about the x axis. So this case is reflect about x axis. And the next continuations will be y is equal to now negative square root of x plus 5. So you are adding to your x value. So adding to x value will be shift left. And then finally, that will become negative square root of x plus 5 plus 6. So notice at this time you are adding to the whole y value, which is the square root part is your y value. So the whole entire graph is going to be shift up 6 units. So let's take a look at how I'm going to graph this. Right? My parent's graph, square root graph is 0, 0, at 1 will be 1, at 4 will be 2, at 9 will be 3, because basically I plug it into my parent's graph quickly and then compute that. And this is my parent graph. Now I'm going to use this parent graph to do the transformations. And notice that I'm going to be transforming 1, 2, 3 in this directions. So my point will be reflected. So let's take a look at this. My first point, this one, at 0, 0, when you reflect about the x-axis, it will be still at 0, 0. Right? And then I'm going to shift to the left 5 units. And then I'm going to shift up 6 units. So this ended up right there. Now I'm going to shift the next point. If I reflect about the x-axis, so this point, when I reflect about the x-axis, it will end up in right here. Okay. Let me erase the other one so that it will make it nice and neat, so you can see which point we are talking about. And then it will shift to the left 5 units. So 1, 2, 3, 4, 5, which is ended up right here. And then after that, I will shift up 6 units from here. So the shift of 6 unit will become at that point. Now we're gonna shift this, transform this point. First, if I reflect about the x-axis, at this point, when I reflect about the x-axis, it will become right here. Right? And and then shift it to the left 5 units, so it will be ended up right here. And then from that, I will shift up 6 units, so it will be 2, 4, 6, which is ended up right here. So you can start seeing the graph already. Now I'm gonna transform this point. So first you reflect about the x-axis. So when I reflect about the x-axis 3 units, so it will go down 3 units right here. And then shift to the left 5 units, down right here. And then move up 6 units, 3, 6, which ended up right here. So now I got my final graph already, which is after I did all my transformations point by point. Now my final graph look like this. So it reflects, shift to the left, and shift up. And that is using the transformations from the parent's graph. And what we want to do is we want to use this transformation idea to graph the parabolas. In the next video lecture, we're going to talk about how to graph this.